we're going to continue our look at slope point form. Remember that slope point form looks like this, right? Where we have our slope, which we use m to represent our slope, and our point, which has a value of x and a value of y. And then remember that we have that weird kind of thing we need to remember where we change the signs on the x and the y to put them into this structure, or to take them up, to take that point out of that structure. Okay, and we'll see that come up in the example here. So everything else is really pretty straightforward when it comes to slope point. It's just that's the thing that students quite often miss when they're doing this work, is changing those signs. So just kind of watch for that. All right, let's take a look at an example that we have on page 3 in our notes here. Write the equation for the line that passes through the point 1, minus 1, and is parallel to a given line. Okay, so here's the line that has a slope of 2/3 and a y-intercept of -5. And we want another line that would have the same slope as that, right? It would have the same rise and run. It would kind of run alongside it on a graph, but it passes through this point here. Okay, we could check if this line here, y equals 2/3 x minus 5, passes through this point, but that's not really what we're doing. We want to write the equation for a whole new line, and we want to, this one's given to us in slope intercept form, but we won't know the intercept of the line that passes through this point, but we do know that we have this point, so we can write something in slope point. And we can write it in slope point because we'll be able to take the slope from this line and use this point to create the line. Okay, so we want to remember that parallel lines have exactly the same slope, and perpendicular lines have slopes that are negative reciprocals of each other. Remember, if we want to find a perpendicular slope, we flip the fraction and change the sign on it. But in part A, we know that our new line is going to be parallel to this line, so it's going to have exactly the same slope, right? The slope will be 2/3, and the point that it's going to pass through is 1, -1. Okay, and just to remember, always our ordered pairs always come in x, y brackets. All right, so if we write this in slope point, let's write our structure here. We just need to substitute. Y is y. We're going to have y, and then our y value for our point. The y value for our point is -1. So remember, we're going to want to change the sign when we put it in the equation. So this becomes y plus 1 equals 2/3 is our slope, and then x, and our x is positive here, so we're going to change the sign. Whoops, I'm going to just write that as a 1. That's supposed to be a 1. Okay, so that positive 1 x value becomes a -1 here. Okay, and this is the equation of a line that passes through this point and is parallel to this line here, has the same slope. Okay, what if we want to do something similar, except we want our line to be perpendicular? It's still going to pass through this point, but we want it to be perpendicular to this line here. So again, our slope isn't going to be 2/3. It's going to be the negative reciprocal of 2/3. So we're going to flip that 2/3 and we're going to change the sign. So our slope becomes -3/2, and we're still going to pass through the point 1, -1. Okay, and everything should look very much the same as the last question, except our slope. Okay, so hopefully that makes sense. A couple of different concepts at play here, right? About perpendicular and parallel slopes, and also using slope point. So kind of watch for both of those concepts. Okay, so this is the part of the unit, this next example, where we need to do some algebra. I'm just going to pause the video. I'm going to write down some notes, and then we'll come back in 1 sec. Okay, so I'm just added some notes for you guys if you want to kind of pause the video and write these down. We want to start whenever we want to change a linear relation or a function that's in slope point form into slope intercept form. Remember that we're just trying to make it look like a y equals mx plus b. And right now you can see that question A doesn't look like y equals mx plus b because the y isn't by itself, and there's brackets in this, this function here. And there's y is by itself in y equals mx plus b, and there's no brackets here. Okay, so the steps that you kind of want to follow is you want to start with distributive property. We want to get rid of those brackets first. Okay, and then what we want to do is we want to move anything that's with the y over to the other side. Okay, so for part A, this one's kind of lovely because there's no fractions. In part B, we'll get some fractions here, and we'll see that fractions can kind of mess things up for us a little bit. But with practice, that becomes normal and totally fine. You'll be great. Okay, so let's start with some distributive properties. Get rid of our brackets first. Okay, so on this side we still have y minus 1, and then minus 3 times x is minus 3x, and minus 3 times plus 2 is minus 6. Okay, we're pretty close. This form here looks an awful lot like this guy. Only problem is we've got this minus 1 here with the y, and we want to move that guy over to this side, and we're gonna add 1 to both sides, but remember we can only add it to like terms. So that 1 isn't like this minus 3x, so this minus 3x stays the same. This minus 1 is like this minus 6, so when we add to it we get minus 5. Okay, so another way to write y minus 1 equals negative 3 bracket x plus 2 is y equals minus 3 x minus 5. Okay, and this can be really handy. Both of them are pretty easy to graph, but this can be really handy because now we can see what our y-intercept is. Okay, we don't know from slope point form, we don't know what the y-intercept is. Okay, so a very clever question I could ask you is, what is the y-intercept of this equation here? And you would not be able to tell by looking at it, but if you changed it to slope-intercept form, you would be able to tell. Okay, there is another way to determine what the y-intercept is without changing it, and I'll let you think about that for a little bit and see if you can come up with another way. You might have to go back a couple of lessons in the last unit. Okay, sorry, we were paused. I'm not sure what's happening. My laptop keeps freezing a little bit, so sorry about the quality of these videos, guys. We'll try to come up with something that's going to work really well. All right, let's just finish this up. So we need to remember how to deal with fractions. Right? When we add or subtract fractions, we need to have like denominators. When we multiply or divide fractions, we don't need. It's still going to be the same as we did for part A, right? We're going to do distributive property, right? Always deal with brackets first. Now, 1/2 times x is 1/2 x, and 1/2 times 5 is 5 5 over 2. Okay, remember 1/2 times 5 is 5 over 2. Right, we can think about that as a 5 over 1 if we have to. 1 times 5 is 5, 2 times 1 is 2. Okay. And now the only thing we need to do is move this 2 over. So we're going to subtract 2 from both sides of our equation. So now we've got y equals 1/2 x, and we need to do 5 halves take away 2. Okay, but notice 5 halves and 2 over 1 don't have the same denominator, so we're going to rewrite this guy as a fraction that has the same value, right? That 2 over 1 is the same as 4 over 2. And now we can just subtract 5 halves, take away 4 halves equals 1/2. And if you can do that in your head, I strongly encourage you. You've been working on that particular skill for years. There's no need to show your work. You just might find that sometimes if the fractions are a little less, I don't know, a little less easy to wrap your head around, then stop and do some scratch work on the side of your paper. Okay, sometimes I do that too, just when it isn't coming to me so quickly. All right, but we're left with 1/2. So y plus 2 equals 1/2 bracket x plus 5 is the same as y equals 1/2 x plus 1/2. And now we know the y-intercept, which is not a nice whole number, which is why slope point would actually be an easier form to graph this guy in. Okay, so that's a little bit more on slope point. Watch the video a couple times if you have to. Make sure your notes are nice and complete, and then do some independent practice. Take care, guys.